All right, we did it. We finished. We finished the brain. Now we just got two sections left. We just got the eyes, and then we got the ears, and then we're done. So hang in there. I think I say that more for myself than for y'all. All right, so let's do some eye anatomy. All right, so we have the vitreous chamber, vitreous humor here in the posterior segment. The anterior segment has an anterior chamber and a posterior chamber. So don't confuse this posterior chamber with this posterior chamber. In this anterior segment, we're going to have, you can think of A anterior for A aqueous. This is going to be the aqueous humor. There's these two chambers separated by the iris, which is where you have lovely brown or blue eyes, and then the pupil, which is in the middle here. So the pupil and the iris are going to separate the posterior chamber here from the anterior chamber there. That's going to be really important for glaucoma. On the very outside of their eyes, what was it, like George Washington, or I don't know, my history, some Revolutionary War guy said, don't fire till you see the whites of their eyes. Well, that's the sclera. So here the sclera is the outside layer. Know that the sclera just kind of morphs into the cornea. The cornea is going to be the outer protective layer. It's gonna play a role in converging light as well. And if you get your eye scratched, it's going to be the cornea that takes the brunt of the blow. Right underneath that, we have the choroid. The choroid is where we're going to have our vascular layer here. And notice that the choroid, as it moves forwards, is going to sort of morph and become the ciliary body and the ciliary muscles, which are going to produce aqueous humor and also play a role in contracting the lens. And it also comes the iris as well. So those three, the iris, the choroid, and the ciliary body kind of all go together. So if you have uveitis, that's going to affect those three. All right, right under that, we have the retina. Of course, this is where we have our cones and our rods, C cones for color. The cones are going to be, so we have this macula here, which is a high density of cones in particular. Cones are going to be for color, but they're also for like vision acuity. So like really like fleshing out details when you're looking at something. So, if you want to be like an art connoisseur, you're going to want to have like a functioning macula. And actually, in the middle of the macula, we have the fovea, which has an even higher density of cones, the highest density of cones in the fovea. And the rods are a little bit more in the periphery, is going to be for night vision. And then, of course, we have the lens. The lens, like the cornea, is going to help refract light and converge it onto the retina, ideally. It has flexibility, right? We have the ciliary muscles, which can make it, become contract and become flatter, or relax and become thinner, depending on if something's far away or nearby. Here we have our optic disc. The disc is the larger one, and then smaller within that, we have the optic cusp. And this is technically a blind spot. There's not actually any retinal cells here. Then we have a retinal vein, a retinal artery. Remember, the retinal artery comes from the ophthalmic artery, and the ophthalmic artery comes from the internal carotid, which mostly becomes the MCA bit. There's a tiny little branch, which is the ophthalmic artery. And yeah, whites of our eyes, iris, and pupil. Whoo! Oh, and conjunctiva. So the conjunctiva lines the eyelids right here. So it's literally the thing lining the eyelids, and it also actually lines the sclera and the cornea as well. So if you get conjunctivitis, it's technically like your sclera, your cornea, but it's the conjunctival layer, like thin membrane right on the outside. All right, so cataracts, really common. I actually didn't know that cataracts were the most common thing. Glaucoma is very common, age-related macular degeneration. I thought diabetic retinopathy was more common. I texted an ophthalmologist friend to see what he thought about this, but he hasn't gotten back to me. So I think it's pretty common, but here they're showing a small thing. It might be that it's really common, but it's just like the silent killer. It just goes undiagnosed for a long time, which we'll talk about. Also, conjunctivitis, for whatever reason, is not here. This is very common. Maybe people don't come in because this is self-resolving. So a couple things that can go wrong with your eye. Cat can scratch you. It's going to hit the cornea first. You can have a corneal abrasion. As we mentioned, the cornea is going to converge light. So does the lens. We want the light to ideally converge right on the focal point of the retina. The difference is, though, that the cornea is static, while the lens is variable due to the ciliary muscles. So if something is far away, the ciliary muscles are relaxed, and we have kind of a thin lens. But if something's really close, we get these diverging light rays. They're diverging rather than moving parallel like we see here. And so we need extra convergence. To achieve that, we contract the ciliary muscles, which makes this become fatter and longer. So we're going to get more time through this refractive lens, meaning more convergence. And so we're still going to hit our target focal point of the retina. Normal vision converges perfectly. Myopia is your eye is too big. You just got a huge eyeball, very long. and the anterior posterior axis. Or it could be that your refractive index is just too powerful, or your lens is too big, or your cornea is too big, or something. For whatever reason, your focal point is in front. So I think of myopia as short. This is the focal point is coming too short. In actuality, what myopia means is that you are nearsighted. You can only see things near. You have a hard time seeing things far away. And that kind of makes sense. Notice that these light rays are parallel. That must be something that's far away. If something was close by, the light rays would be a little bit more diverging. And if they're diverging, well, then it's going to be harder for them to converge. They might actually converge then on the retina. So you can see things close because of the diverging rays. Hyperopia is the exact opposite. Your eye's too short, or your refractive index isn't powerful enough. And you can see, you definitely have a hard time seeing things that are close because of these diverging rays. But if something's parallel, you have a better chance of seeing it. So if it's far away, so you're farsighted. Myopia is, if someone's born with vision problems, is more likely to be, you need glasses, a prescription when you're 10. It's more likely to be myopia than hyperopia. And astigmatism is you kind of got this like football-shaped lens or cornea. And I actually think it's the cornea more than it is the lens. Hence, this is ghosted a little bit. So the cornea, maybe the lens, is kind of like weirdly shaped. It's irregularly shaped, and so kind of like a football. And so there's actually many different focal points here, here, and here, and it creates this blurred vision. Presbyopia. So as you get old, your eyesight declines. It can happen for a lot of reasons. Most notably is that the lens curvature changes, the elasticity changes, or probably the most important one is the ciliary muscle strength changes. Remember that the ciliary muscles are necessary to contract, to widen the lens so you get more convergence. If you can't do that, if you can't converge very well, you're going to have the focal point be behind the retina theoretically. So this is actually going to mimic hyperopia in a bunch of different ways. And I think of this is where the term comes from, the Presbyterian Church. The whole idea here is that the church would be governed, represented by an assembly of elders. So presb means elder, and this happens in old people. So that's actually helpful. Anytime you see presb, it's talking about like old age and whatnot. People can have LASIK surgery to repair presbyopia, myopia, hyperopia, astigmatism. I really don't know. I'm talking out of my ass here, but I would imagine that it works better for myopia and astigmatism, because myopia, the idea is that your lens is too thick, or your cornea is too thick. So if you shave down on the cornea, you're going to have less refractive distance, and so that's going to be make it converge more quickly, and the less quickly, and so it goes focal point gets pushed to the right a little bit. In astigmatism, your cornea is irregularly shaped, and so the lasers that we're using to reshape your cornea is going to that seems an easier fix, but I'm sure it's more complicated, and there's ways you could change the shape so that it actually deals with hyperopia as well. All right, so glasses. If you have myopia, again, you're converging too quickly. So what do? We say that we're myopia because we want to see things that are near. Something near, the light rays are diverging. Well, instead of having something be near to your face, you could just put a diverging lens to diverge it on its own. If you diverge it on its own, then it's got more work to do, more converging to do before these light rays meet up. And so it actually now might hit right on the focal point of the retina. And it's the exact opposite if you have hyperopia or you have presbyopia. You cannot converge light well enough, so you need extra help with converging, so you now have a convex lens. So this is going to be a positive diopters, this is going to be negative diopters in terms of the focal points. Cataracts, so this is the most common thing. My friend who's an ophthalmologist, he just does cataract surgeries, and that's because it's crazy common. So you get these the crystalline protein in the lens is what is responsible for most of the refraction as light moves through. This is a normal one. But as you get older, these crystalline proteins break down and start to aggregate, and you get this cloudy lens, and so the light doesn't really focus very well, and some of it, maybe not all of it gets through, it doesn't focus, etc. And so you have a lot of vision defects, especially at night, because not as much of the light is getting through. Age, smoking is a big one. Just don't look at the sun. All of the torch infections for pregnant ladies, galactose metabolisms, and there's a bunch of genetic defects that can affect this. And so this is what it would look like. Everything's just a little bit blurry. Everything, not just the center. That's important. Here we can see a cataract eye and a normal eye. And cataract surgery, we take out your shitty cloudy lens and we put in an artificial one. A dislocated lens someone smacks you in the face or something, the trauma is probably the big one to cause the lens to shift out of position. But also a couple of matrix structural protein defects, so like Marfan syndrome. Homocystinuria can also cause this. They love to ask this. It's silly, but it's important. Marfan's goes up and out. Homocystinuria might just go down, but some people say that it goes down and kind of medially down and in. You can see that here as well. Conjunctivitis, so you're just going to get an eye infection. Well, actually, it could be allergies. Could be allergies. If it's allergies, it's going to affect both eyes equally. If it's an infection, you're going to have one of your eyes be like a red eye. It's swollen, it's painful, and a couple of days later, it shifts over to the other eye. And actually, I'm not sure if it's painful. I would fact check me on that. Some of these are painful and some of these are painless, and that's actually important. I think this is painful, but I'm not sure. In any case, jumping over to one eye to the next is definitely high yield in a vignette to know that it's an infection. Adenovirus is the most common cause of conjunctivitis. Remember, this lines the eyelid and it lines the sclera in the cornea. Another way you can get red eye is uveitis. So uveitis, remember that the uvea is the cord, and the cord, as it's moving through, part of it becomes the ciliary body and the ciliary muscle, and part of it becomes the iris. This is associated with autoimmune conditions like arthritis and ankylosing spondylitis. I have ankylosing spondylitis, and I actually had an episode of uveitis, and it wasn't great. It wasn't horrible, but it just kind of stinks. All right, so here we're looking at the anterior segment of the eye. Here we have the vitreous humor in the posterior segment. Here in the anterior segment, we have a posterior chamber, and then we have an anterior chamber. And they're going to be separated for the most part. So here's our lens, mostly separated by the iris, which is right here. And then the pupil is going to be right there. So the fluid is produced by the ciliary muscle, by the ciliary body, and it flows through here from the posterior chamber into the anterior chamber. And I'm sure it's got lots of nutrients and important things, and so that's why it's there. But we don't want it to be there forever, right? We need like kind of a circulation. We need it to drain. So 90% of it is going to go through the trabecular meshwork, which is a lot of resistance. And so we want just like a Goldilocks zone. We don't want too little resistance. We don't want too much, an appropriate amount of resistance. And then it's going to drain into Schlemm's canal and then the episcleral vein to get out of there. And 10% of it does go a different pathway, not shown, known as the uveoscleral drainage, which is going to be important for medications and treatments of glaucoma. So glaucoma is where we have too much pressure, typically because we have a buildup of aqueous humor in the front of the eye. So here we have this humor, and it's causing more pressure than we would like, and it presses on this optic nerve. Pressing on the optic nerve, so this is going to be normal and healthy. But if I have too much pressure here, too much pressure, I'm going to like take some of this vitreous humor and these redness and these veins and arteries, and I'm going to like push them inwards, and you get this eye cupping, and it looks like this. So remember that the optic disc is like the large thing here, and the optic cusp is going to be the smaller, like more central bright circle. Ideally, we want the disc. So, oh my gosh, the cup should have 1/3 the radius of the disc. So, in other words, if the optic disc we measure is like 3 millimeters, then we want this to be 1 millimeter or less. But when you have the glaucoma and this high intraocular pressure, the pushing out enlarges the cup. So now this might be 2 centimeters and this might be 3 centimeters. And now we can diagnose that as glaucoma. Two types of glaucoma. So you can have just an obstruction of drainage. So again, the ciliary body produces the aqueous humor, and it goes here. It should go through this to the canal of Schlemm and the episcleral vein and whatnot. But if there's too much resistance for whatever reason, we're going to have a buildup, and that can cause glaucoma. That is open angle, because this angle right here, this angle, theta angle, it's open. It's normal. The angle closure can happen for a variety of reasons, but you can see that this angle is very small. So it's not that the trabecular meshwork is too much resistance, or we can't drain for. That's not the issue. The issue is just that it's just not the limiting factor is not enough can get through here because this angle is too small. It is a narrow angle closure. So associations, open angle if you're African American or if you're particularly old. For angle closure, if you have Asian ancestry. Mydriasis, remember that meiosis is pupillary constriction, mydriasis is pupillary dilation. I always remember that because mydria is a lot longer than myo. Meiosis is a shorter word than mydriasis, and so mydriasis is for the pupil dilation where it's bigger. This is going to it's also going to be very painful. Narrow angle closure is a medical emergency. It happens all of a sudden, and people are going to see halos. So let's go back to mydriasis. Why is this going to be a factor? Well, here again we have the here's our iris, and here is our pupil. Turns out that when you dilate the pupil with these radial dilator pupil muscles, you are going to make this angle smaller. And when it's constricted during meiosis, it makes this angle bigger. So pupillary dilation is going to be a risk factor or a potential cause here. All right, the retina. So light is supposed to come in, it's supposed to converge right on the retina. And if we zoom in a little bit here, it's converging right on the retina on these cones or rods, and then they're going to go up to the amacrine cells and the horizontal cells, and I don't even really remember. It gets processed, and then it comes up, and now it's going to move through the optic disc. And remember that there are just axons traveling here, and so this is a blind spot because we don't actually have any retinal cells to process something. So something we didn't talk about earlier, but here if I'm looking at the retinal layer, also shown here, right on the other side of that, remember, is the choroid and then the sclera. So right on the other side of the retinal layer, we have something called the retinal pigment epithelium, RPE. And then again, here's the sclera, here's the choroid, which has the vasculature, right on the other side of the choroid is something called Bruch's membrane. So we have the retina, which is next to the RPE, and then we have the choroid, which provides all of the nutrients in the blood, which is next to Bruch's membrane. So RPE and Bruch's membrane are right next to one another. And so we mentioned this before, there is a high density of rods in the periphery. Notice it's not so much in the periphery, right? This is one of the reasons we have the accommodation reflex, right? Your eyes are going to look inwards, your pupil are going to contract, and your ciliary muscles are going to contract as well, so that you are better at converging. Because we don't want I don't want super diverging light coming in and hitting this, because I don't actually have a lot of retinal receptors there. So that's why we're going to, try to get light to hit somewhere along this part of the retina. So nevertheless, the periphery has more cones, and then as we get to the macula, specifically with the fovea in the center, we're going to have, it has more rods for the periphery. This is now going to have more cones in the macula and the fovea, higher density. Again, cones see color, visual acuity. They require a lot of light, though, to work. The periphery is going to be a little bit more sensitive to light. And so for night vision, where there's not a lot of light, that's going to be less the macula fovea, and the cones working, and a little bit more the rods in the periphery working. And you can kind of see this as a mathematical graphical distribution here. Okay, again, blind spot, macula with the fovea in the center with all of the cones. And notice that these veins are fatter, and they're a little bit more opaque, and these arteries are going to be thinner and a little bit more translucent. Retinitis pigmentosum. This is a genetic disorder. It's a genetic cause, and there's actually a lot of different genes that cause this. It just causes the retina to degenerate over time. Specifically, the rods will be affected first, and then the cones. Because there's so many different genes, it might affect some people early, some people middle age, and some people as they're older. And affecting rods first. Remember, rods are the peripheral vision. So the peripheral vision and the night vision go first. This affects dogs, actually. A couple of breeds of dogs, one of them being cockapoos. My dog, Lulu, here is adorable. Her favorite thing in the world is to chase tennis